get started. Thank you everyone for coming, and I appreciate you staying late on Sunday. It's understandable that some people couldn't stay, but I really appreciate it. My talk is titled, Yes, the FCC might ban your operating system, but that's not the real problem. And that sounds a little clickbaity. My blog that was titled this, someone said, well, that's clickbait. Well, yeah, but 40,000 people looked at it, so I guess it worked out because it's actually a serious problem. So just a quick introduction of myself. My name is Eric Schultz. I'm an independent software engineer and open source consultant. I've worked with these companies and organizations in the past on open source software. Most recently, I am still with Purple as their community manager, and that's kind of where this entire topic started for me. In particular, they do a lot of work with OpenWRT because a lot of the members of Purple are very interested in OpenWRT. So this topic kind of came up, and then I kind of just went with it, and it kind of snowballed, it seems like. So an introduction. This was my blog that I had posted, and I didn't really expect that many people would read it. I kind of figured there'd be a few people in the free software community that would get a little excited, but nothing too big. Well, it turns out that the Purple blog had about, on average, about 20 people visiting per day. It was pretty low traffic. And then one day, when this was posted, we had 35,000. That was a big difference. And to suffice it to say, the executive director was very happy that we had all these people coming. What's that? Absolutely, absolutely. That was good too. So I don't know how well you can see that, but I was real proud of this. I was at first number 3 on Hacker News, and I'm like, oh my God, I have to call my mother. And then I was number 1 on Hacker News, and then I was like, I really have to call my mother. This is amazing. I don't read Hacker News that much, but it's pretty cool. So this blog really kind of made this issue snowball, and we ended up the actual proposals, which I'll talk about in a second. It had about 4,000 comments, with almost none of them in favor. And it was opposed by groups, as you can see, the Free Software Foundation, Open Source Initiative, Software Freedom Conservancy, Google, Boeing, which was one that surprised me, Research Labs, the ARRL, the Amateur Radio Relay League, OpenWRT, DDWRT, Mozilla, Think Penguin, I spelled Linus Torvalds' name wrong, and Vint Cerf, as well as doctors, service members, hams, developers, and more. This was, FCC doesn't get too many comments on kind of obscure proposals that often, especially like this. So we'll talk about kind of what the proposals and the rules are that started this whole fiasco, I guess the best way to call it. And we'll go into some detail and some definitions of what the FCC actually does, which I think helps us understand what their proposals and why they're there. The two particular proposals are the UNII rules, which I'll explain in a second, and the Notice of Proposed Rulemaking, NPRM, on the E-Label Act and the modular transmitters. And we'll go into that in a second. So first, let's talk about some background on what the FCC does in this space. FCC, the people don't really know what they do that well, and they're a very large agency with a lot of people and a lot of funding, and they handle a lot of different things. So they do kind of two things in this space that's relevant to us. And and for the hams in the audience, I'm sure this is overly simplifying, but these are the big ones that are relevant to this topic. They regulate radio spectrum users. Radio spectrum users the radio spectrum goes from it's in the kilohertz. I don't know the exact number, and then it goes into the hundreds of gigahertz of radiation. And users are people like you and I, theoretically. They're people that are using your laptop, your phone, the TV stations, things like that. To illustrate why they do this, this is a radio spectrum map from 2003, and this covers from about 4 gigahertz to 10 gigahertz. You don't need to know exactly what all those are, but you can see it's pretty crowded, because each one of those is a different type of user with a different type of use case and can do different things. So the key is that this radio spectrum is a finite resource. We can't expand it. Additionally, different parts of the spectrum have different use cases. In general, lower frequency has a better ability to penetrate structures and travel long distances at lower power. Now, there are some subtle differences, and I am not a physicist, so I can't tell you all of them. But generally, that's the case. For example, the 2.4 gigahertz, which is what some Wi-Fi uses, as well as Bluetooth and some cordless phones. There's a bunch of other things. That can go a pretty long ways and can go through a number of walls. 60 gigahertz, which is a proposal for some very short-range data transfer that is being proposed, I think, with the IEEE. It can go a few feet. It can go very high speeds, but it can only go a few feet. I believe one person told me that if you put a leaf in front of it, you could block it. I don't know. Yes? What's that? Oh, okay. Okay. Well, that's partly my confusion, but they do have different use cases, I think, each of these, and different advantages. The spectrum is split into 3 categories. There's the part that no one can use, the part that everyone may appropriately use, and the ones that licensed parties may appropriately use. Licensed parties, they're different classes of users. They're amateur radio users, commercial operators, which include radio, TV, mobile phone, armed forces, safety personnel, air traffic control, and each user must meet some sort of requirement to be licensed. In some cases, I don't know if they're necessarily all that complex to actually be licensed, but they do have to meet some sort of requirement. And in particular, there are certain things that only they can do. Now, I mentioned appropriate use, and this depends on user and frequency. Appropriate use involves regulation of frequency, power output, and modulation technique. This is actually relevant to some of the FCC's proposals, so that's kind of why I'm bringing it up. Why power matters is it's a spectrum sharing technique in part. If you can only go, if you limit the range of networks because you limit the power, you can actually put more people to use the network because one network's not going to interfere with another because it can't go as far. There's one more side of appropriate use, and it's primary and secondary users. The issue is, what if 2 groups need the same slice of spectrum? I think there may be cases where there's more than 2. But what if one is, quote, more important than the other? The FCC solution is to share the same spectrum, but secondary users must defer to the needs of the primary users, and this is also really relevant. So to illustrate that, the FCC does have enforcement for this. In particular, in this use case, they fined Verizon Wireless $50,000 for not meeting certain requirements. In this case, which you cannot see it very well, there's actually a $25,000 fine for a ham radio operator that was not appropriately using the spectrum. Important notes. Unintentional violation is illegal and can be punished. Intentional and negligent violations will not be looked upon kindly. And if a user learns a transmission is interfering with others, they must stop the interference immediately. So what's the second thing that the FCC does with radios? They regulate marketed devices. And these are the devices that we're actually buying in some cases or whatnot, or using. And it might be unclear. It's like, well, we can regulate the users. Why are we regulating the devices? Well, the problem is devices can behave badly. They can cause interference. And if the users are legally responsible, we don't want users breaking the law and getting fines for no reason. Manufacturers are required to use accepted best practices for engineering, and as I said up there, I'm sure they occasionally do. Devices are regulated also by use case. Part 15 devices, which are unlicensed devices like Wi-Fi, have different requirements than Part 97 amateur radio devices. The things they can do, the power output, certain things like that are regulated totally differently. Now, I've been using this word device, and this is important to how the FCC regulates devices that are actually in the market. Is what is this definition? And personally, I didn't spend a ton of time, but I've never found the definition. It doesn't seem to be very clear what the word device means. Now, in the case of Wi-Fi, we can understand what it implies based upon what they've required in the past. And it doesn't just mean the hardware portion of the radio, but it also doesn't mean all the software on the radio. To me, it seems to be implied to be the radio hardware, and the software which can control the radio parameters. Now, that's a little vague, but that's the best I've been able to come up with. So the question you might be wondering is, like, how much software actually controls the radio parameters? And it depends on the particular device. One question that I've used to try to understand as best I can is, where is the last barrier that can override all radio control decisions? Where's the last place that happens? And to me, that's like where the device ends, as far as I can tell. And again, this is not well defined, so this is kind of a lot of people guessing to understand what this actually means. So it's important to actually understand, like, how Linux Wi-Fi regulatory actually works in these use cases, because you have these. We're talking about, like, where does this stop? Where does the device end? All these things, and it's important to actually understand how Linux actually works for wireless. First of all, you get a command that somehow goes into the kernel. Then it goes into a driver. The driver then, at some point, either uses stuff in the kernel to understand its how it should handle the request, and then sends it to the firmware. And then all that obviously goes back if there's something that has to be returned. To improve this work, the Linux kernel has a regulatory subsystem, which basically is kind of like a best practice for handling the domain regulation and the different regulatory domains. And this can be shared between drivers, but it's not required to be shared between drivers. Some use it, and it's kind of a good idea because it's highly audited and it's reusable, and it's kind of just open source how it actually works. We all agree on that. And this takes care of managing the regulatory domain, which includes the legal requirements on power, on frequency, on DFS, which is actually very relevant to this topic. If you're set to the U.S. domain example, and you say, I want the radio to go onto a channel where DFS is on, but I don't want to turn DFS on. The kernel, this regulatory subsystem, would say, no, you can't do that, and would basically return some sort of error along those lines. So the question of where the device ends. It includes the radio firmware in almost all cases. It includes the driver in most cases. And if the driver does not have an internal regulatory system and uses the kernel implementation, the device ends inside the kernel. So now that we have the background, which is unfortunately very long, we can talk about the UNII rules. And this is when the large-scale lockdown the rules began. It hasn't been totally enforced yet, but they really started putting these rules in place. The FCC approved new rules to restrict the modification of UNII devices. UNII devices are Unlicensed National Infrastructure Initiative, or 5 gigahertz devices. That's your 5 gigahertz Wi-Fi, things like that. They proposed a rule that started, all UNII devices must contain security features to protect against modification of software by unauthorized parties. So you might be thinking, well, that's not necessarily bad. It's a security thing. You don't want people from the outside modifying devices. That's kind of reasonable. But there's more. Now you can read this whole blob of text. You don't really need to. Some key points. The manufacturers must implement security features so that third parties are not able to reprogram the device to operate outside the parameters for which the device was certified. The software must prevent the user from operating the device with operating frequencies, output power, modulation types, or other radio frequency parameters outside those that were approved for the device. The FCC then gives examples of ways manufacturers can do this, including electronic signatures on software. So you're first starting to think, this sounds a little bit like DRM. Additionally, manufacturers must take steps to ensure that the DFS functionality cannot be disabled by the operator of the UNII device. Oh, there's even more. From the instructions that they give to hardware manufacturers to comply, it specifically says what prevents third parties from loading non-US versions of the software/firmware in the device. Describe in detail how the device is protected from flashing and the installation of third-party images such as DDWRT. They literally put the name of an open source project in a rule that they disliked because they disliked it that much. That's a fair point. The people that influenced them didn't like the rule. It's a little bit of both. We'll talk a little bit more. So the question you might be wondering is why 2014? I mean, we've had Wi-Fi for a number of years. Why is it now? Well, until then, the only Wi-Fi that was running on 5 gigahertz was 802.11a, which was extremely old and relatively slow, and it was an alternate band for 802.11n. Now all of a sudden, 802.11ac is the standard for high-speed wireless, and it only runs on 5 gigahertz. So there's a problem, because 2.4 gigahertz is just too congested at this point, and the channel sizes are much larger. We're going from things that are 20 megahertz. The standard allows things up to 160 megahertz wide. Now, the 5 gigahertz band is obviously 1,000 megahertz. And you can't use all of it, actually. There are restrictions. Portions of it are towards the top, in particular, are disallowed. So you can't fit too many channels in there. Sadly, something else is also there. Terminal Doppler weather radar. It's high-precision weather radar. It's used at about 50 of the busiest airports in the country and more around the world. It's in the middle of the 5 gigahertz band, but it differs slightly across countries, which just makes all this more fun. So the question would be, how does the FCC actually manage this problem? Because you can't just have Wi-Fi, transmitting interfering with these radars, which is understandable. So they use something called dynamic frequency selection. A DFS was required for operators and for manufacturers since early in the last decade. Anytime an unlicensed 5 gigahertz Wi-Fi device is on a shared frequency, it listens for a special signal from the terminal Doppler weather radar. If it hears it, the device negotiates a new frequency with the client and switches to the new frequency. It's actually required, I believe, to do it within 10 seconds. As a backup, 5 gigahertz Wi-Fi routers could only be operated inside a building until 2014. This was the extra protection that they had. So the FCC has some logic, because now they know that this Wi-Fi standard is coming out, and realistically, if this is the high-speed Wi-Fi standard, they're going to have to put some of these outside. It's not practical to not do it when it's all running on 5 gigahertz. You're going to have some outside Wi-Fi. So if we can't restrict it to indoor usage, and we want to make sure people can't turn off DFS near airport, then our only solution is to lock everything down. I'm not sure that's actually the best solution, but that's kind of their logic. So you might be wondering, this has got to be a huge problem. People have got to be interfering with this all the time. Planes are crashing, terrorists are destroying everything. It turns out they've had 10 cases in 7 years. All involved for-profit companies. AT&T, for example, who were breaking the law. And the reason is because in areas that are near airports, you know that DFS is basically going to disqualify a few of these channels all the time. And they only had like 14, I think it's actually 11 channels in the US. in 5 gigahertz. I could be wrong on that. There's a certain number. And they were losing a bunch of them. But they were selling citywide Wi-Fi in San Juan, Puerto Rico. And they didn't want to have to put in more of these routers. They wanted to be able to use all the channels. So we'll just turn off DFS. They were basically endangering people because they wanted to make more money. Now, these weren't tinkerers. They weren't average people. They weren't people trying to control their routers that are running their lives. These are for-profit companies that are acting irresponsibly, and they were fined for it. There aren't many of these cases, though. Most could have been avoided by simple UI changes to manufacturer and third-party router firmware to eliminate unintentional violations. One thing that was really interesting is there was one router that was shipped that was shipped in one of these cases that actually had a box that said DFS on or off. Now, I'm going to say that that's not reasonable. That's not something that should be shipped by default. Additionally, there was some third-party open source firmware that was also basically allowing people to do something similar in the UI. That's, I would say, irresponsible as a default. So now we're going to have problem number 2. Because the UNII rules basically went into effect last year, or about June last year. They seem to have been delayed, but it's really vague because everything in the FCC is really vague, basically, as best I can tell. They're not seeming to be enforced, but they're on the books, that they could be enforced at some point. I think I found something that said that it was that basically they were exempting things that were imported into the country. I'm not sure if it was covered in this case. It was unclear, and I'm not a lawyer. I've had lawyers tell me a lot of this stuff, but this was not an area that I had clarification on. But I do know that it has been exempted, at least for a period of time. Problem number 2 is the E-Label Act on modular transmitters, and SDRs and a ton more. An NPRM is a notice of proposed rulemaking. This basically is when the FCC says, we think there's a problem, and we want to make a rule, but we want to talk about this first. And basically, people can send their comments, and you know, they can ignore them and whatnot. And this was a really long NPRM. It came out in August, and they give you by default a month to actually to comment on this. And this thing was just, you know, like hundreds of pages long. It was just ridiculously long, and it covered all kinds of topics. So it's important to talk about definitions. Modular transmitters are approved transmitters that can be added to hardware without requiring approval of the whole device. It's kind of an add-on. Basically, the goal is the FCC and a lot of these companies basically want to be, I can just snap this thing in, and I don't have to get my device approved anymore because I know I'm not modifying anything, and the transmitter's been approved anyway. The E-Label Act is also in here, and it's an act of Congress to allow electronic FCC labels instead of physical ones. They have to put these certificates of conformances on boxes. They sometimes put them in boxes or in the manual, things like that. Most people ignore them, but they are required for devices. So the goal was, well, let's just, to reduce cost, let's just have them somehow put on the device in some sort of UI if there is a display on the device. So, and I feel I should have shortened this up. But basically, for devices including modular transmitters, which are software-defined radios, and use software to control the radio, they have to describe it. They have to state which parties are authorized to make changes, and the software controls that are provided must prevent unauthorized parties from enabling different modes of operation. Manufacturers must go into detail on how to secure the software in the application for equipment authorization. It must include a high-level operational description or flow diagram of the software that controls the radio frequency operating parameters. The applicant must provide an attestation that only permissible modes of operations may be selected by the users. That last one seems to be kind of hinting at the UI problem, I think. There's a second part of this, and right in the beginning, it kind of says the problem. Manufacturers of any radio, including certified modular transmitters, which include a software-defined radio, must take steps to ensure that only software that has been approved where a particular radio can be loaded into that radio. And we can go into the details, but it also includes things like digital signatures and basically the same stuff we saw in the UNII. So you might be wondering, what's a software-defined radio? Basically, the radio logic has been moved into software, much of it. This is actually a very vague definition as well, because things that are called software-defined radios previously were not software-defined radios in the FCC's mind, and vice versa. It's very confusing. It allows complex algorithms that were kind of impractical to do in hardware for reliable transceiving, which is transmitting and receiving. It handles beamforming and even a DFS to some extent. Hardware could be sold in a wider range of use cases with these changes in software, which is kind of a benefit because, all of a sudden we're opening up this stuff that was, you had to have the electronics built a certain way and it would only do these certain things, and all of a sudden we can start expanding this out for people. And as it said, a broader range of people could innovate or experiment. The history of software-defined radios. And this is actually, Cory Doctorow's actually talked about this quite a bit. He actually wrote a blog post on this a few weeks ago. Toward the end of last decade, the FCC saw SDRs and were pretty horrified. Instead of educating and enforcing laws, they wanted to avoid needing to come up with a better plan. They wanted to avoid it by needing to come up with a better plan. The FCC would certify that SDR software doesn't violate rules, signing all SDR software with an FCC key, and requires software to only run FCC-signed software. As you can imagine, this was not a popular plan. And it was totally impractical because they could never verify all of the software actually didn't break any rules. So they came up with a better plan. They told people to secure the SDRs, but they didn't tell them how to do it. And the FCC said it was possible for open source software to be used for securing it, but it would have a high burden. There were separate approvals for software-defined radios and non-software-defined radios, although the devices aren't technically all that different in many cases. And there was a more difficult approval policies for SDRs, but they were slightly more flexible in what you could do. They're mostly used as niche products for hams. From what I can tell, the SDRs aren't actually that secured. As I said, I haven't investigated much, but I didn't see any obvious way that they were. Maybe they are. And it's possibly due to the FCC being worried about the lack of a market. So the question is, why are we talking about it? Well, they admit in the NPRM that the SDR market is pretty much doomed, and the approval is just way too difficult right now. So they're going to get rid of this distinction. And then apparently make a bunch of devices meet some of the SDR requirements, including securing it, which were too difficult and didn't succeed in the market. I'm not sure why they feel this is a good idea, but they did. So the E-Label Act. This is another dangerous part of this. It allows manufacturers to show the certificate of conformance on a display instead of a piece of paper. The rule proposal reads, the necessary label information must be programmed by the responsible party. It must be secured in such a manner that third parties cannot modify it. Now, this is potentially not as dangerous as the other parts of the NPRM, but it's still very vague. Because the question is, what does it mean to be secured in that the third party cannot modify it? Now, if it literally means we can write this onto a write once ROM or flash or something like that nobody can modify, and you don't have to actually make sure it's displayed on the device, then this isn't actually very harmful. This is perfectly fine. If they want to enforce it and say basically that you go into your system preferences in your phone and your certificate of conformance always has to be there, well, how the heck do we do that and allow people to replace the firmware on their phone? Because if we allow people to replace the firmware on their phone, they could make sure that the certificate of conformance doesn't display. We're not sure what this means, and again, it's kind of a proposal, so I think they're a little loose in the language. I'm not sure if it actually came to a rule, whether they would be as unclear about it, but it's possible they would. So, anyways, we had this big blog at one point, and the FCC got to the point where they responded, which was kind of interesting because you don't think they really care about these things. So they were a little caught off guard. A spokesman said in some of the articles that the policy didn't affect open source operating systems, which is absurd. And a confidential, high-ranked FCC official said they felt that there was a way to comply and protect open source. And as I said, apparently 4,000 people didn't agree with him. And I personally have a suspicion that the high-ranking official is the chairman of the FCC, in part because of this next part. The blog post was done by the Chief of Office of Engineering and Technology, and was titled Securing RF Devices Amid Changing Technology. The Office of Engineering and Technology, as I was quickly learned, actually is very much run through the chairman's office. And they have been discussing why this is so vital. They're basically the people that actually understand the technology involved as best they can. As obviously the people on the FCC are not all people that are engineers and physicists and all those kind of things. So basically, the blog said, we don't tell you how to secure the radio, and that you can't use free and Libre and open source software images, but you have to secure the radio. And we're not opposed to open source as long as you can secure the radio. It kind of missed the point. So there was a reply period, and this chief of the Office of Engineering and Technology wrote another blog post called Clearing the Air on Wi-Fi Software Updates. It was just warm and fuzzy. Basically, we're going to work with these stakeholders. We changed the UNII guidance to not mention DDWRT anymore, which they did. It was very warm and fuzzy sounding, but they didn't actually say they were changing any of the rules practically, because the UNII guidance basically said, well, you still have to make sure, still have to explain how you're going to prevent people from modifying the radio and the firmware. So realistically, it sounded really nice, and a lot of people were like, oh, it's very warm and fuzzy, you're going to work with people. And they didn't do anything. So I has a mad. So I decided to respond to this on my blog. And as part of that, I asked 17 questions that the FCC should have clear answers to before moving forward. And I'll discuss them as part of one of the problems with all of these proposals. They have not responded. Maybe they won't respond. By the way, is anyone from the FCC here? Oh, interesting how that is. No, but it was after the NPRM ended. They do contact with people, and I do know people who have contacted them. My point is really that they feel like this idea that they're going to be all this warm and fuzzy, but we're not actually going to do anything and meet you on your own turf or contact you or say, hey, you brought up a good point. Let's talk about this more to figure out a solution. The NPRM is not really a very good mechanism for coming up with collaborative solutions. I appreciate that. They can't have ex parte discussions, though, which they do. I don't know. We did comment. There was a number of comments. They were done with the comment period is when I brought this up. Yeah. So we're going to talk about the workarounds. And a lot of people feel like there's workarounds. We can get around some of these problems. In particular, they're going to lock down the entire device, which I don't think is particularly a workaround, but it's there. One of the ideas is running the radio firmware on a coprocessor where root can't touch it, or in some kind of mechanism that where you can't interfere with it. Something like cell phones. We do that with cell phones. And I say that these are both unacceptable and they should be completely condemned. They're terrible ideas, and there's a lot of reasons why they're terrible ideas. So you might be wondering, what's the problem with lockdown? It takes away control from users and puts manufacturers completely in charge. Manufacturers, at this point, have to lock down devices. But since they have the key, they're the only ones who can decide what goes on that router. How often is your router updated? Okay. Good point. There are security holes. If there's a security hole in your router and you can't modify it, how exactly do you protect yourself? Unplug it? Well, now you've just thrown away like $100 or whatever because your device can't be fixed if they choose not to. There's unintentional violation by the users due to bad hardware. For example, the unintentional violation, remember, is a crime and is illegal. Additionally, the user has no control over the hardware at this point. So basically, we punish for running hardware that you have no ability to fix. Your best chance is just turn it off, which again is $100 down the drain. There are functionality limits. Most of the radio firmware doesn't actually have very good support for a number of features. One of them is ad hoc networking, which is used, or ad hoc Wi-Fi, which is used for mesh networking. It's incredibly poorly supported usually because it's not a very big market. It usually has to fall on the community to actually improve it over time, and they have. The second problem with lockdown ignores that different users have different privileges. Hams, for example, have a much different set of rules and things they can go under. For example, they actually at scale earlier today, the Hams had a Ubiquiti router running on, I think it was 3.3 gigahertz. I could be wrong on that. That's right. Which only Hams can use. I mean, average Wi-Fi people, unlicensed users can't use it. This is also, I believe, used by public safety personnel, and they potentially could have it running at a different frequency. And Hams in particular, this is actually a major one, is in disaster recovery. They use the mesh networks to help disaster recovery because you need to have data coverage over a very large area where all of a sudden none of the lines are working. And you need to be able to do this across, let's say there's been a tornado or something large like a hurricane. Hams go out of their way to help with this. And this would not be possible if Part 15 devices were restricted to only doing things that unlicensed users can do. It ends low-cost wireless radio research. There's a ton of this actually being done simply because research equipment is extremely expensive. And you can just use a router. Why bother? I mean, it works perfectly fine. Research labs actually were some of the people that complained about this because they're like, well, we can't test to see if this device actually works the way we wanted unless we can make sure that we can modify it. And FLOSS community members have done things in the past, such as finding bugs in radio firmware that they submitted to Qualcomm Atheros. And I've heard of someone who's actually working on algorithms to handle reducing power in transmissions if the quality of the signal is high enough. Basically, this is a way to reduce radio interference because obviously, again, if the power is lower, it's not going to go as far, it's not going to penetrate as far, and that increases the quality of the spectrum for everyone. These things would pretty much be eliminated. It prevents the use of devices across some borders. And this is an issue that is particularly for service members. There was a U.S. service member who actually submitted a comment and said, basically, I'm going across borders. I'm transferring around the world. I want to comply with the requirements of the Wi-Fi because they're all slightly different in all these countries. And right now, I can go into the kernel and I can modify. I can switch the country code, and I'm using the correct Wi-Fi frequencies and where DFS is and all that kind of stuff. This would be impossible. This person would have to buy a router in every country. That makes literally no sense. It's incredibly wasteful. And I mean, are we going to just give these out to U.S. Army members? Like, what are we going to do? Additionally, business folks, people who travel between countries, it's absurd. We don't live in a world where we all just live in one country and we never go anywhere else. We travel all over the world. You need to be able to make this work. So the question is, why are they doing this? I have suspicions. I don't know if they're all correct, and in fact, probably many of them are not. But one thing is it reduces enforcement cost. I think this is actually probably a major part of it. As with any federal agency, budgets get cut, and over time they have fewer and fewer people to do enforcement. Additionally, in the summer they had closed a number of local enforcement offices. I think there were 3 or something. I'm not sure on the exact number, but to illustrate, they want to reduce their enforcement costs. If they know people can't actually modify things, they're not going to have to enforce the law because it's just not going to exist, they think. That's unrealistic because obviously people can import things and we all have all these old routers, and it's a very silly idea. But it potentially could reduce their enforcement costs. A possibility is they may want to sell part of the spectrum and need a way to actually enforce that sale is valuable. Obviously, if they do so, that whoever buys it is going to pay billions upon billions of dollars potentially, and they're not going to want to buy something when they think that there's going to be tons and tons of interference. One thing that is happening that is, I think, mainly they're not selling it, but is related to this, is something called unlicensed LTE. And there are a number of companies that are cell companies that particularly are concerned that basically they have their bandwidth is getting sucked up, and they've bought tons and tons of this bandwidth for billions of dollars. It's unbelievably expensive. And they want a way to actually put this on the unlicensed spectrum. So they're trying to get approval for something called unlicensed LTE. And basically it is, you could actually put the LTE data transfer on the unlicensed area of the spectrum. They claim it wouldn't interfere with Wi-Fi. I don't know if that's true, and honestly I'm probably not qualified to tell either way. However, there obviously is competition for the spectrum. The FCC I don't think, trust individuals. I think they are fundamentally view innovation and particularly innovation and experimentation on some level as something that companies do. They feel that the market should solve this problem on some way. They like high-tech solutions to social problems, and I've had a lot of people say, well, basically there's not enough of this spectrum out there. Wouldn't it be great if we could just make sure that people didn't break the rules so we could just fit everything in better? I think another way of handling that would be to actually teach people and punish people for breaking the rules, but that's a different opinion. And I think they want the regulatory world before software-defined radios. To some level, before software-defined radios, it was really easy. This was a Part 15 device. It could only do this. It could do nothing more. There's no way to. The hardware didn't allow it. You would have to solder things and all kinds of things. They view it as users of Part 15 unlicensed devices are consumers. They view ham radio operators as experimenters, tinkerers. And they view companies as innovators. And that is not the world we live in. It is not in any way the world we live in. Each one of those people may apply in one of the other areas. They may innovate. They may experiment. They may consume. It's not a straightforward, you're in this area and you're in this box and that's all you do. It's far more complex than that. And I feel that that is what they don't appreciate that or simply don't care. So the question is, what is the solution? They need to work with manufacturers to make sure modification of radio parameters actually requires reflashing. I think that's an appropriate idea, in that the default should not allow you to break the rules effectively. If you flash something, it's on you. And it should specifically say, if you're flashing a new piece of firmware, it should say, okay, basically warn you, you could break the law doing this. This is very serious. There's a very severe punishment for this. Make sure you know what you're doing. It's kind of a buyer beware, or in some cases when you flash your phone, you lose the warranty. It's like that kind of concept. They could work with the free software community to make sure default UIs aren't dangerous. That in the example of the firmware where it allowed you to just click a button and turn off DFS or use frequencies you're not supposed to use, make sure the defaults aren't dangerous. Make sure that people actually have to go to the effort of recompiling if they want to break the rules. One of the things is that the quality of this firmware, the radio firmware that most hardware companies release, is very low quality. And we have no ability to trust much of it. We don't know if it's actually breaking, in many cases, the FCC's rules that require, because it's not really audited very much. The FCC should require the release of radio firmware source code. That's a big ask, but I think ultimately, given the world we're living in, where we have IoT devices and we have lights that can, do all these things. You got your thermostat. We need to have some level of trust that this actually works. Now, I would argue that they should be open source. I think for this case, it should be open source or viewable. I would like it to be open source, but I understand that that the government probably cannot enforce something like that, because that is pushing it in a certain direction. But I think that they may need to get some level of authority, but I think at least the release of the source code for it to be audited would be at least a step in the right direction. This is probably going to be controversial. I think hams should work more on protecting the spectrum for everyone, and vice versa. This is why I said it was going to be controversial. In the ARRLs, in almost all the hams that submitted replies that I saw, many of them were saying, protect the right of hams to modify devices. Now, I can understand why hams are doing that. At the same time, I would argue that we're in this together. That ultimately there are very powerful people that want to start taking away spectrum. And if they start taking it away for unlicensed users, they're going to try to take it away for licensed users. It'll be tougher, probably. Hams are extremely well organized. So I think this needs to be extremely collaborative approach. And this is not a criticism of hams as much as let's just look outside the box more at how this problem is affecting all of us. Yeah. I agree. I'm actually a licensed ham, so. Yep. Yeah, I have my technician. I don't think I've ever used it, honestly, but I am a ham. So, additionally, there should be a collaborative campaign to discourage inappropriate usage. If this is a problem, there are ways to actually discourage people from doing this. You can actually teach them that it's actually harmful to turn off DFS. You can do things along these lines. We have educated people to not do dangerous things in our society for many, many years. One example that I've heard is the concept of drunk driving. Drunk driving is far less common than it used to be, simply because as a society we've changed and we have considered that outside the norm. Now, again, this is a little bit of a different concept, but there are things we can learn from that, and that could be a practical solution. Additionally, there should be fair, firm punishment to those who break the rules, particularly if they endanger others and do it for profit. I don't think that there's any doubt that should happen. No, I don't think it is. Particularly in this area. They do it for licensed area. They are allowed to it if you use it in a way that is against the rules. They did, for example, they did do that in the case of the AT&T where they turned off DFS, because that is illegal, and it was in the unlicensed spectrum. They are allowed to provide fines. They're simply not doing it very often, which indicates to me either it's not a very big problem or they don't care about the problem. Yes. They're not enforcing the rules in this area, or there's not. It's not happening that often. They're not listening. They're literally not listening to this. I I agree with you. They did extend it, and that indicates that there was a problem. The issue is that even when they finished that and they had the reply period, they stayed in the exact same spot they started with, realistically. I mean, this isn't a ham or not ham thing. This is simply protecting the spectrum, which is something, to be quite honest. I mean, the FCC exists to protect this for people. I agree. I, this is a political process. The the first blog post, the second one was not responded to. I was somewhat being sarcastic at the point. The point is that there is a very large problem because there isn't any collaboration that's actually happening. It is not happening. If there was collaboration, there would be actual discussions happening. Now, I understand that's difficult in the case of the FCC. However, they did not have any problem going to CES and discussing, talking, and taking pictures with the T-Mobile CEO. It was on his Twitter feed. They're not coming here to take pictures with. Yeah, yep, absolutely. Um, we can create better tools for the community to find, discourage lawbreakers. This is actually Cory Doctorow's proposal. I don't know how feasible it is, but obviously we all have devices that have radios in them right now. Could we choose to install software to actually report and triangulate where lawbreakers actually are? I don't know. I don't know the feasibility of that. I know you can do some level of triangulation. Um, I don't know. Something to consider. Again, it's ending the forcing of people and devices in these regulatory boxes. It's not quite as simple as this person does this thing and this person does this thing and this person does this thing. it's a lot more complex. It doesn't mean that we should just say, well, don't regulate the spectrum. No, you absolutely have to regulate the spectrum to protect it for everyone. But people go between these areas. They use devices in unique and valuable ways. That is part of what is American innovation. And this, they need to understand that and appreciate that as part of their rules. So, questions and discussion. Yep. Hmm. Hmm. Yep. Hmm. Yes. I, I I would agree with you. My point is simply that there's when I said there's a set of things. One of them is simply making it so that people don't do these unintentional things, discouraging the unintentional violation, because that is a serious issue in the FCC. So one thing that we can actually look at is make it so that if somebody's violating it, it's very likely that they're violating it intentionally. So, yep. Hmm. Hmm. What are the ramifications? Lockdown. I mean, that's a possibility. I mean, I don't know where it goes. That makes it hard. I, I maybe one thing that I think is important is simply, and this is probably part of just the fact that rules and the federal government bureaucracy is very complex. Is with the lack of information about the UNII router rule, is that there's these cases where people are companies are locking it down, and it's unclear why they're doing it. Some of the times they claim it's for business purposes, and other times we're not sure. And the truth is because of the vagueness of the rules, and simply because you need to have a lot of experience to understand how this all works. Some of which I mean, even though I've been working on this for parts of 6 months, I still don't understand. it's unclear what the rules actually are in the case of routers. And this is another side of the same problem.